Okay, folks. This is a FICM out of Ford 6.0 liter diesel. They are notorious. And I'm going to show you how to get them apart and fix them. Oh. Gives you a bad boy screw or drill because the little ones are not going to cut it. T20. This sucker's a little quick here. Get y'all in a little better spot. Got two 20s on the back plate, or T20s on the back plate here. Alright, regular screwdriver. You get the back plate off. Once you get the screws out, just pry it up and it'll come off. This is a 4-pin FICM, and you will want to use a T10 by hand on these. These you do not want to strip. Alright, once you get that done, I take a small screwdriver and I'll try to get in between the cracks here. Small screwdriver and a hammer. Just any thin bladed screwdriver. Typically start that thing cracking open. You hear it pop and crack, and you want to go on this end, alright? Because this end, when you open it up, does not contain any circuit boards down there that are, well, it does, but it's not like super close. Alright? Actually, I guess it doesn't matter what end you work on, it's the same. The circuit board's not super close. Just don't drive your screwdriver down any deeper than just a little bit there. Just a little bit to get in there, about that deep, and you'll be fine. They come apart pretty easy. Got more T20s in here. Ooh. Now these caps pop off. And you got T20s here, 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 and here. However, see all that amber shit in there? It's got to be moved out of the way. It's like a dampening for these capacitors and etc. So you want to move that out of the way. So I should have cleaned my bench before we started this. Show you how we get that out of there. Or how we get down to those screws to get them out. Okay. Okay. I take my hot air, crank up the flow a little bit, and I melt that crap off. You just want to melt it down until you can get to the head of the screw. That's going to soften that stuff up enough that you can get it out of there. Just one more to go here. It's easier to work from this side. Once you have that done, you're done with your hot air. Turn your hot air station off. Get your screws out of there. Again, these are T20s. The screw doesn't come all the way out of that amber stuff. As long as you get it loose, that's all you want. The board is going to come out whether the screw's stuck to the amber or not, so not going to be a big thing there. Alright, now you get a big regular screwdriver or a door panel tool and you just kind of pry up. Doesn't take a whole lot, and your board's out. Set this aside. Now what we want to get at is 4 little resistors. Here, 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 and here. You can look down through that amber and it will say Dale R0075 on the top of the resistors, and if you've got a factory OEM FICM, those things sometimes I have seen them blow completely out of there and through that amber. They get hot. Apparently they get hot. So you don't want to use the heat in that area. What I like to use is I've broken this one already, but it's got a little chisel tip to it, much like a regular screwdriver, except it's a tiny bit sharper. And I just start kind of cutting me a channel through that stuff. You'll see why here in a second. It's adhered to the capacitors. And then as you cut a channel, sometimes you have to cut more, sometimes you have to cut less. This one didn't require too much. Now it's going to require a little bit more. Be very careful not to cut through a channel that is on top of any of the components underneath. So find you a clear space on the board to cut your channel. And just like that, you can get to your resistors. So you have to be able to kind of see through this stuff and see that you're not getting into any of the components underneath. If you get into them, you are likely to lose this little ball game. So those little components underneath, they are important. So I get to an area. I usually do one side, start peeling it up, peel it back, it's going to break away from itself. Hopefully it breaks away enough that you got plenty of room to work. So now we got plenty of room to work on these. The other thing we need to do is we need to clean all around these 4 holes. I'll clean that one too. I'm not sure that's really needed, but it's not going to hurt. A regular wire brush will do it. But I use a little Dremel tool with a wire brush. Flip it over and get the back side of those as well. I just got a real light pressure, probably just the weight of the tool that's pressing down. I don't have a whole lot of pressure. It's not like I'm grinding on this thing. I'm just letting it brush any corrosion away. Hope you could hear that. That's what I was saying was, I'll say it again since the tool was running. It was kind of loud. I just had a light pressure on it, not too much. Just let the tool work and it'll brush away any corrosion or anything that's built up on there. Now, well, flux goes a long ways. I use Amtech. You want to get your flux on there, both sides. Roll off a little bit of solder in there. Solder here. Heat up the edge of that resistor. Sometimes when you do this, they will fall off because they're just barely on there. Let that solder get on there and adhere to the pad underneath it, underneath the resistor. Some people say you don't want to, so let's do a little example of that. Some people say you don't want to bridge those 2 resistors together because that is very common for the solder to wick from one to the other. Let me show you something. Got the meter set on continuity. We're going to put a probe on that resistor and a probe on that resistor. There ain't nothing in between them resistors. There's 0.00.0 on the meter. There's, if you bridge them, it ain't gonna matter. Alright. But if you want to be pretty, you can try not to bridge them. And there's nothing wrong with these resistors. They're just letting go from the board. So basically all you got to do is get them back on there. And get them on there good. Sometimes the solder doesn't like to stick to them, which is the case today. Okay, now see, I heated one side of this, and I don't know if you can see it or not, but the other side is floating all over the place. That's because that one side was not even. This side, the left side, if I'm looking at it like this, was not even attached. So I'm going to have to position that back on there in its proper spot so we can get to both pads. It takes a little work to get it to where it needs to go. I've got it where I need it. I got it bridged right now and it's ugly, but now that I've got that side tacked down, we're gonna get this side done so that we can, so it'll quit moving around on me. Flux. What I did was suck off the excess solder from where I had to get them stuck back down. And now we have them done. Nice and pretty even. Let's start work on the other side. These will come in two different varieties. They will come OEM and they will come aftermarket. The aftermarket ones are a real pain in the butt, not made very well. Got different looking resistors on them, but they are in the same spot. They just don't say Dale R0075, but they are still same value resistors. And whatever you're using, okay, this thing is just going to bridge them both and go with our old process here. Heat work for a minute. There we go. Now we got adhesion. These can certainly be cranky up. I'll do this again. No, we're not. Okay. Alright, that one's done. Let me get a little bit more over here. There's enough of my iron. So now both sides, done quite nicely. Alright, so now we work on the back side. Back side, I like to do the same process with this though. I brush these. And, whoa, this is a good example. Let's see if you can see this. This is cracked all the way around. This one's got a crack starting. These two have got cracks. This is from vibration. are these caps. So anyway, now that we've shown you, we can brush these. They tend to take solder a little bit better. We're knocking off oxidation off the top or something, but they tend to take solder better. Now, that little prissy tip, that ain't gonna cut it. You need a big honking tip on this one. These caps suck up the heat big time, so you need a lot of heat. A lot of heat, little magic juice. And clean your iron, and you should be good to go. So, I'm sure glad I removed that little prissy little tip, because this is working good. Alright, now every place that you used this crap, you got to clean it off. The best way to do that, douse it with alcohol. It kind of breaks it down, thins it out, and scrub it off with a cotton tip, or these are foam applicator tips here that I'm using. They tend to work better. These foam applicator tips are cheap, and buy them on Amazon, and you don't have to even leave the shop. And the thing I always say is clean until it's not sticky. As soon as it's not sticky, then you sufficiently got it off of there. I use 99% alcohol. You don't want to use the alcohol from the drugstore because it's 87%, so that means it's 13% water. Water's got all kinds of contaminants in it. Alright, now we get down in here and get this. We also use some flux in there. The flux will corrode your circuit board after a while if you don't clean it. You're asking for trouble. And if I'm going to ask for trouble, I'm going to do it over something a whole lot more fun than flux. not allergic to trouble, but it tends to come with a little bit of a cost, so I'm going to make it worth my while. Okay, we are all clean. We're ready to go back together. Oh, got a little screw there that seems to be trying to get away. People ask me all the time if I test these things. Do you test those things? I test it by sending it back to you. But there's, unless you're gonna keep a 6.0 diesel laying around just to test these things, I don't know of anybody that's really, I mean, they may say they can test them, but I mean, we test continuities, things like that, but come on. You basically have to keep a truck laying around just to test them. Where's my drill? There we go. What the hell happened here? Oh, this is a different drill. It's like, I know I didn't change my bit. Where did my other drill go? What did you guys do with my other drill? There it is. Hiding that crap from me. I don't know where my torque setting is. It looks like it's pretty damn high. We're going to turn it down. It's still pretty high. Screws back in there. That's a little better. Alright, don't forget your black caps. Doesn't matter which one goes on which side. They're both the same. Alright, first thing you want to do is put your, there's those T10s back in here. I thread them in before I tighten them. If there's a place to be cautious, this is it. Do not use a drill on these. You will strip them. You may get away with it for a little bit, but eventually you'll strip one and you got a problem. They make 7-pin ones, and there's 3 more screws than this right here. It's the same process once you get the screws out. Alright, inspection plate can go back on. You can measure your 47 volts right there with it in the truck. These are particular screws that hold this down. Don't know where the other one is. These you can put in with a drill. Oh, it was just different coloration than the. Alright. Now, just I go a little crisscrossy on these so it tightens up evenly. Yeah, sort of. I go around, but I skip a hole and then I fill in. Y'all can't see hardly anything. Oh my god. Bad YouTuber. Bad. Be careful with these because they're starting to get older and you can pop the head of these off pretty easy. So don't put too much torque on these, putting them back in, just enough to get the job done. Alright, that is pretty much that. We've got covered all the bases, I think, so that's it. Like and subscribe. Hit that notification bell if you want to see more. As soon as we pop this bad boy back in, it should be making 47 volts. And I hope the customer's happy. You guys take it easy. I'll see you next time.